Hi, my name is Ken Lasseson. I founded Microbiome Prescription, and by training is operations, research, statistics, etc. Just today's video is going to be very much a technical one for people who are data scientists or microbiologists. And what I'm going to do is look at, I'm not sure if you call it naivety, stupidity, dumbness, or laziness. But basically, the problem I'm seeing is that many data scientists tends to push data into a data model, get the results, and report, and that's it. They never actually look graphically at the data. I was taught to always look at the data, to chart the data to look for abnormalities, which will often blow up. Oh, it's not what I thought it was, and you having to iterate 3 or 4 or 5 times until the data and your model are in sync with each other. When you use a canned program to calculate machine learning or something like that, you don't see these abnormalities. In fact, you pretend they don't exist. Um, the most obvious first thing I came across was the fact that microbiome data is highly skewed. I covered that in another post I've done there. And then in that, I dug into a couple of things because I was interested in odds ratio of having it, and I discovered something that looked basically like hate to say it, more like electron shell density from when I was doing honest physics, and not the nice linear model that's often assumed. So I ended up grinding through data. I have a big set of data to work from. Which with a large number of symptoms with it. So what we end up doing is we want to review condition, and I found things end up in four groups. One is condition line versus reference line is clearly to the left. Basically, that means the transform average, keyword transform average is less. Condition line is to the right, transform average is more. So, okay, something is higher with something with a particular condition or something is lower condition. Then we hit the oddities, which similar to above. The condition line is on both sides of the reference line. In other words, sometimes it's higher, sometimes it's lower. A complex situation. That is the one which means we don't do anything. The lines are effectively on top of each other, no association. So let's go down, and here is a nice simple one where we see the condition line, which is the bottom right, is to the left, which means that if you calculate the transform average, you will find it there. But just out of curiosity, if you notice it, it's only when the amount gets above a certain amount that is significant. It's not absolutely everywhere. It could be, but it's not. Next one down is far more clean. It's to the right, higher level, and it's across the board. Basically, okay, this one is higher average. You run with the non-alcoholic fatty acid disease. Go down further, and we get a mixed case where for low values, it's on one side, on higher values, it's on the other side. It's confusing, and of course, the last case is when effectively the lines are on top of each other. Okay, at this point, I'm going to jump over and give you a slideshow or a video presentation of a whole stack of different microbiome, all from the same program here, and just walk through it. And the whole purpose of it is for you to look at them and ask yourself questions. Okay, so we're into it, and here we have one which is one side is on the other. Again, here is one where we have a number crossing. Again, bottom right is the characteristics being examined, as well as which data set I'm using. For example, biome, uBiome, and Ombre are the main ones I have large collections of, and you can see we have some very clean. It is that one is less. Number one, which tends to be less, but only for higher values. Again, this one is sort of sweet. We see it's definitely to less. Here we have it's to the more in general, and then down the bottom it's such. So basically, I'm going to almost shut up now and just let you watch the differences, and it's just interesting. And again, the conditions are the bottom right. the reference source is at the bottom right, and the bacteria being examined is at the top. So I'll shut up and enjoy. Just as an FYI, I did mention the word transformed, and that goes back to the original post I cited, where you want to find the ideal monotonic increasing transformation of the data so that you can get the highest R squared between two bacteria in terms of association. That transformation which I found a couple which work well is what I use to generate the model, and then I scale the model to be the transform data to be from 0 to 100 just to make it easy, and the charting now becomes much easier, so not having numbers all over the place from the transformation. So everything being scaled to 0 to 100, and across the bottom here is the percentage in the sample, which is straightforward. So the, it was a bit of fun building the model. It took a lot of a lot of CPU time. I'm upgrading my main analysis machine to 64 gigabytes because I just find I need more memory. Okay, I'll shut up and I'll continue watching the pretty pictures. Okay, I'm starting it now. I am going to go and produce a much bigger sample set of charts for people who really want to be brutal. Okay, have a good day. Enjoy and start thinking about the data and the graphics of the data.